In this video, we're going to do an introduction to Ansible and go through a couple of the basic plays that we might see in order to automate some of our tasks. Now, your first question probably is, what is Ansible? Well, Ansible is a system that is designed to automate several management tasks. There's a lot of other systems management utilities out there, such as System Center Configuration Manager from Microsoft. There's Chef, there's Puppet. There is a lot of different systems management tools and automation tools out there. Ansible is fairly unique in the fact that there is no client, no agent that needs to be installed on the remote machine. Instead, what happens is Ansible will actually connect to remote machines via either FTP or, Telnet or SSH in order to remotely manage that computer. This does add a little bit of complexity as far as your networking design may be concerned, but it also enables the system to work a lot more flexibly as far as the client PC is concerned, client PC or server, simply because that means you don't have to install anything on it, and it can run as optimally as possible. So this works on Linux, Unix, Windows, and network equipment. It is quite frequently used specifically for network equipment because of the fact that it runs via SSH or Telnet in order to remotely log into machines and make configuration changes. Ansible uses what's called idempotent scripts. Idempotent, however you would actually say that. The idea there being that it is somewhat intelligent with its scripts. For instance, if I told you to, here's a Windows computer, go ahead and install Microsoft Office. Probably the first thing you would do when you open up the Windows computer is to check to see if Office is actually already installed. Because if Office is already installed, your task was to install it, but it was already there, so there wasn't actually any need to perform the task. That's what the idempotent scripts mean, is the fact that it is somewhat intelligent, that if you tell it install software and that software is already there, it's not going to try to reinstall it. Or if you say make a configuration change and that change has already been made, there's no need to make that change. So it streamlines the operations a little bit as far as not making unnecessary changes, but it also optimizes the uptime of the system, since a lot of software installations or configuration changes require associated restarts of services. The idempotent scripts can identify that there's no need to restart the service because the configuration was already there, and therefore the system uptime retains or stays fairly high. And that also means I can rerun that same idempotent script every 5, 10, 30 minutes, and it will always make sure everything's up to date and only make any changes if a change is necessary. Ansible uses what's called plays, and then these plays are grouped together into playbooks, and it utilizes an inventory file. And we'll actually get into those hopefully by the time of this video is finished. Installation of Ansible is actually fairly simple. You can either do it in a couple of different ways. First of all, if you are on a Fedora type machine, Fedora, Red Hat, something like that, you can do a yum install Ansible. Or if you are just simply a Python person, you can do a pip install Ansible. Actually, let's go ahead and kick that off. So here I've got my my Fedora 30 machine. So I'm just going to do a sudo yum install Ansible. That's for the password. And then it will install, or it will check all the catalogs. It will install all the necessary updates along with it. And when it's done, we will be able to continue on with the install process, or with it being installed. So here is a diagram of what our network looks like, with an interesting white line right in the middle there. Basically, we have our Ansible machine over here on the right hand side, and then next to that is Web 1, Web 2. Web 1, Web 2 with IP addresses 192.168.0.1.1.1 and 112. And then down below we have our two database servers with IP addresses ending in 121 and 122, and then lastly our network gateway of 250. All right, so the inventory file. This is essentially what an inventory file would be. In fact, let's go ahead and let's get started here. So here I am in back to my machine, clean, clear. Excuse me. Ansible has gone ahead and installed, and I'm going to just create an inventory file. I'll call this inventory.txt. Using the Vi editor, one of my favorite editors. What I'm going to do is I'm going to start off with a section called all, and we use the square brackets to define our sections. So web 1, and because I don't necessarily have DNS working fully, or maybe I don't trust the DNS, I'm going to actually add in Ansible _host equals and the IP address 192.168.0.11. Same thing for web 2, Ansible _host, no spaces, excuse me, 192.168.0.112, db1, Ansible _host, 192.168.0.121, and db2, Ansible _host, 192.168.0.122. Now, I'm not including the router in here because that is currently out of our scope of configuration. Now, what we can do with this, now that we have our hosts in there in an all section, and there's other ways you can do this. You don't necessarily have to create an all section. But now that we have all of our hosts in this section, I can then create additional sections simply for my management of it. For instance, if I want all my web servers in a single group called web, I can create a header or a group called web and then put web 1 and web 2 in it. Now, because web 1 and web 2 are up here, it's going to remember, oh, web 1 and web 2, these are our IP addresses. So those are the IP addresses I use down here. Let's do the same thing for DB, DB1, DB2. And then let's create a group called backup. And for right now, let's just put DB2 in there. So with that done, escape :WQ for write and quit. And we now have our inventory file. So for Ansible, we can do what's called an interactive or an ad hoc method. So we can do an ad hoc method of just by calling Ansible -i for inventory, and then we say what our inventory file is. That's inventory.txt. Inside of inventory.txt, remember we have lots of different groups, and so we can actually call out an individual machine, such as this, and we say -m ping. The -m means go ahead and run the command of ping from my computer, from my Ansible machine. -k -u just in case. So what this is going to do is it's going to use the username of just in case in order to log into this web 1 machine. The -k here means it will prompt me for Justin's password, and then it will run the ping command back to my Ansible machine and basically tell me if I can communicate. So when I hit enter, it asks me for just in case's SSH password and super secret password 01. So I go ahead and type that in, and then Ansible should come back very briefly with ping was success. Nice little deprecation warning. For now, we can go ahead and ignore those. So it says web 1 was successful. Let's see, changed false. So I sent a ping. It responds back with a pong. So that was just with web 1. Instead of saying web 1, instead of saying just that one specific host, I do actually have a group of hosts called web. So if I run that, again, type in my super secret password, this should actually run that ping command on both Web 1 and Web 2. So here I can see Web 1 and here I can see Web 2. So I could start using groups in order to manage these machines appropriately. And as you saw, a machine can be in more than one group, or a group can have one or multiple machines in it. So I can actually start organizing these as I possibly want. So I can have an overall web group, and then I can have a production web group and a dev web group. All the machines in both production and dev would fall under the dev group. And so I could do one task that targets all of my web servers, or a task that targets just my production servers, or just my dev servers, or just individual servers in and of themselves. Just to get the other machines, let's go ahead and do the same thing with our DB machines. And there we go, DB1, DB2. Of note, DB2 actually responded back prior to DB1. This is one of the great things about Ansible. Ansible actually parallelizes these tasks. So when I said go ahead and run this on the DB group, it actually spawned off two different tasks, two different SSH tasks. And then whichever one returned back first, in this case DB2, got reported on first. And then DB1 got responded back second, so it returned back second. So it wasn't a serial operation. It didn't do DB1 first and then wait until it finished before doing DB2. It did both at exactly the same time, which speeds up the overall process. And then lastly, we had, I guess we have two different groups left. We have actually a database, which we know is going to work because it's just DB2. But then we also have an all group. And this should highlight the random order of the responses even more. DB1 returned, then Web1. No, excuse me. DB2 responded, then DB1, then Web1, then Web2, which is not the order of the VM names in the inventory file. All right, so that was one ad hoc command, which was just the ping. There are other ad hoc commands. In this case, instead of doing -mping, I'm going to do a -a and a couple of quotes. The -a actually says go ahead and run the command that is included in the following quotes. And so here I can do any command I might possibly want. For instance, if I do a df-h, df tells me how much disk space is available on my hard drive. So if I run this, it's still going to ask me for my password. It will go ahead and run df-h on all 4 machines and tell me exactly how much file system space is left. The -h, by the way, is what shows me megabytes versus gigabytes versus kilobytes, as opposed to just simply big, huge numbers that are very hard to understand. So df worked. We can also do other commands such as free-m, which shows me the memory space on each of those machines. So we can see for memory, there was a total of about 2 gigabytes of RAM. 568 are used, 705 are free, and then there's some buffers. Same thing with the swap file, which is on the hard disk. And we can actually see, yes, these are different between the machines. DB2, for some reason, is using more memory than DB1. Same with Web1 and Web2. Memory usage can vary depending on the machines. Now, let's say we want to do something a little bit more than just simply reviewing status of the machine. We're getting a directory listing, such as ls/. Let's say we actually wanted to do some sort of an administrative command. We can still do the same thing, except instead of just simply doing simple command. Let's try, say, reboot. A Linux command. As you can probably imagine, it will in fact do a reboot. However, not every user can reboot a Linux machine. You have to have administrative rights in order to reboot a Linux machine, which means we have to do a couple of switches. As we saw before, whenever we were making changes, we had to do the sudo command. Like when we installed Ansible, we had to use sudo yum install Ansible. And that allowed us to run as a super user. Here, for Ansible, we need the same thing, but we need to tell it to use this sudo command, which we accomplish by adding a -b on the line. B, actually, let's by doing Ansible -- help, this actually tells me what all of these options mean. There we go. Information here. Specifically, if we look for -b, right down here, become, which means run operations with become or sudo. Note, it does not imply password prompting. In order to do that, we need to add the -k command to ask it for the sudo password. All right. So let's try that. Let's change our ls to a reboot, a -b for become, and then an uppercase K for asking for the password. And here we'll see it's asking for the SSH password. And then it asks for the become password, which defaults to the SSH password. So if the SSH password is the same as the sudo password, I can just hit enter right here, or I can retype in the password itself. So I'm going to go ahead and hit enter. And it's going to be a little boring here because it's going to say, hey, we failed to connect. Well, it actually connected. It is actually connecting. And in fact, in the background, my VMs are rebooting. So it did actually connect. The reason why it came back with that error message is because it never finished the reboot process, because it disconnected me. All right, so I told it to reboot, it disconnected me, therefore it's not finishing the process and can't tell me that it succeeded. So that will continue on, but basically we can run any kind of sudo-esque command utilizing these ad hoc features. So our machines are rebooting, and while they're rebooting, let's talk about a few options we have here. Let's see. So that was our inventory, our ad hoc commands, other ad hoc commands. And now let's talk about our passwords. So we've been using the username of just in case and typing in password 01 as the password. And while that's been working, it's been kind of tedious that every single time I want to run that command, I've had to type in the password. Anytime I've wanted to run any command, I've had to type in that password. So one of the options I can do is I can use an SSH key. SSH key basically is a certificate that is installed on one computer, and then a public key a public-private key is generated. The private key is kept on the local computer, and then the public key can be pushed out to a remote computer, and the remote computer can trust it. At that point, anytime somebody logs in with the public key, it's automatically accepted. Let's see what exactly that looks like. So I'm going to start off by, on this computer, let's clear this. I'm going to generate that key. So SSH-keygen-t for type RSA. Asks me where do I want to save the key. I'm just going to choose the default. It asks me if I want to passphrase this or secure it with a password, essentially. I'm going to say no. So I just hit enter twice. And we'll see that it created two different files for me. Then there's an ID RSA and an ID RSA pub. In fact, I can even look at these /home/in case .ssh, And I can see I have 3 files here. The ID RSA is my private key. ID RSA pub is my public key. And the known hosts are hosts that I trust, or known keys that I trust. So what I can do to make this work is copy this public file into the known hosts on other computers. I'm sorry, into an authorized keys file on other. And we do that such as, let's clear this out. I'm going to SSH into 192.168.0.111, and I'm in here. I'm going to make dir-p the .ssh folder. The .ssh folder may or may not exist on that host. So now it does. So now I'm going to cat. I want to cat my .ssh/id_rsa.pub into an SSH session to 192.168.0.111. And there, once I'm on that host, I want to cat this into the .ssh/authorized key. Again, I authenticate in order to get my password set up, and then lastly, I connect back in one more time, and I run the command chmod 700 for the .ssh folder, and chmod 640 for the SSH/authorized keys file. Alright, so that was a lot of steps, well, 3 steps actually, but it seems like it might have been a lot of steps. At this point, however, if I SSH into 192.168.0.111, what should happen is it should log me in without prompting me for a password. So there was a little setup. There was a couple of different lines for setup here, and hey, maybe I can automate this at a later date. But there's a couple of lines to set up there, but once they're set up, it allowed me to log right in, just call SSH with the host, and then log right in using those keys. I didn't have to type a password. So if I do this on all of my hosts, it logs me in automatically. This also has the added benefit that I don't have to manage passwords. I don't have to keep track of them. I don't have to worry about changing them every 6 months or 3 months or however frequently I normally change my passwords. I can simply keep my keys there and then only change the keys if I feel there's a need to change the keys. So that's the passwordless option. And if that was confusing, don't worry, you can just go ahead and go to Google and type passwordless SSH, and there's lots of people that walk you through how to set up SSH login without a password. This guy right here from TechMint, this is actually pretty easy to understand. They even walk you through some GUI or some videos here of how you would actually do it. All right, so that's passwordless. The other option, specifically with Ansible, is next to where we say Ansible host in our inventory file, we can actually add an Ansible SSH user and Ansible SSH password. Now, general security policies say that this is probably a bad idea. This inventory file is a text file, and what we're doing is we're putting a username, not just a username, but a password and username combo in a text file that literally most anybody with access to this computer would be able to access. So not ideal, but potentially more flexible. Oh, I'm on the wrong host. Okay. So if I go into inventory.txt, here at the end, I can go ahead and add in Ansible underscore SSH underscore user equals just in case. Ansible underscore SSH password pass 1. And then because they're consistent amongst all of my hosts, I can actually copy, paste, so again, not ideal, but it does actually work pretty well. At this point, if I go back up to one of my Ansible commands, let's not do the reboot one. There we go. Let's try the free. I'm actually going to get rid of the -k-u. So U was for the user, K was for prompting for the password. At this point, I should just be able to leave it as is. It will now look in the inventory.txt file, read the username and password out of it automatically. So one or the other ultimately is what you should do. Passwordless is probably more ideal, a little bit more difficult to fully understand possibly. The password, however, is a little bit more easier to understand, but less secure. All right. So we've been doing that pretty good. We've got Ansible installed. We're connected to our remote machines. We can now execute one command or multiple commands if we chain them properly amongst multiple machines. That's awesome. Let's go ahead and let's do it the way that we would actually do it in a larger production environment, which is to actually create a playbook. So let's go ahead and create a playbook. I'm going to create a directory called tasks. And inside tasks, I'm going to create a file called play1.yml. A YML file is called a YAML file. YAML stands for yet another markup language. You gotta love naming schemes. But YAML files, they have a fairly distinct markup language, a fairly distinct way of being able to show how things are printed. And what we do is we start off in insert mode. And we do 2 dashes, dash space, and then we start our content at this point. So for instance, I'm going to say hosts, and in this scenario, I want to target all hosts. So here we're looking at the groupings in our inventory files. This could be hosts, this could be all, this could be web, or this could be like web 1. So I can choose an individual host or all hosts or some grouping therein. At this point, to enter, what we need to do is we need to line up where we say hosts with our next line. So what I need to do is I actually need to hit space twice. So now I'm lined up with the word hosts. For my hosts, I want to run some tasks. Now tasks has subtasks under it. So in that case, I line up with tasks and then I do a dash space and the name of my task. The name of this task I actually want to be create a directory. Create temp directory. The naming doesn't necessarily matter that much, but it does help out later as you're running it. And you'll see how that name comes in handy. Alright, so just like before when we did hosts, we lined up with the H. Here when we did name, and now we line up with the N on the next line. So 2 spaces, and there we are. In this case, I want to do a file task. So file : and then enter. 2 spaces, and now I actually need to indent 2 more. And the name of the file or the destination want to be /tmp/ let's call this ANS for Ansible. And then same thing, line up with destination. In this case, I want it to be state. And I want the state to be touch. Alright. So we're going to leave it fairly simple. Basically what this is saying is for all hosts, do the following tasks. Here's the list of tasks. There's just the one, so it's just a list of tasks. And then the name is create temp directory. And in there, it's going to do a file command with a destination being tmp/ans. And it's going to do a state of touch. Nope, correction, not touch. Directory. That's what I need. Because I don't want to create a file, I want to create a directory. Now, if I had multiple tasks in here, what I would do is I would line up here with this guy right here, and I would do another dash and then another name, and I'd call this another task. But for right now, I want to leave it just like that. So let's go ahead and exit that. Escape :WQ. And now I want to call my playbook. Now, because our Ansible inventory file has our passwords or our SSH keys are already distributed, I don't need to worry about usernames, but I can call Ansible-playbook-i inventory.txt. I don't necessarily need to specify a group at this point because the group is already referenced in the playbook. But I do need to specify the playbook. So tasks/play1. And I hit enter. Mapping value is not allowed. Alright, so it doesn't like hosts all. Look back at that. Oh, I think I see it. It's supposed to be 3 dashes on the very first line, not 2. Could it be that simple? Computers are really, really picky. Alright, so it does a task. It starts off by gathering the facts, and it says, yeah, okay, DB1, DB2, sure. It then does the task, creating temporary directory. That's the name that I typed in for the task. And then at the very end it says, yeah, okay, these guys all said okay, and a change was registered for all of these. Now this is where the idempotent comes in. If I rerun this script, if I just simply up arrow and hit enter, it should try to rerun the same script, but changed is going to be 0 because nothing changed this time. It already created a directory, nothing changed, there's no need to change it. And so now if I, let's see, actually I've got a couple of windows open here. If I SSH into 192.168.0.111, first off, this is the machine that has my password already there. And if I do an ls/temp, I should see right here my ANS file. If that's too small, forgive me, well, there's a reason for it being quite so small, which we'll actually do right now, because we want to actually do a watch command in that location. Oops. And I want to run that on multiple machines. So the watch command, what it does is it keeps running the ls command in that directory, and we'll see how that comes out here. So that was our very first task. Let's talk about our next one, which is where that watch command will come in. Actually, I'm going to go ahead and do the same thing. I'm going to log into 112. We didn't do the SSH passwords for those guys, so I have to manually type them in and run the watch command. Well, Alright, so let's go ahead and let's edit our playbook again. We'll go back to play 1. We'll stay with this guy for right now. I didn't mean to run it, I meant to edit it. Alright, so now what I want to do is I want to create another task. Call this name, create a temp file. Another file command. This time the destination will be /tmp/ans/file. And the state will be, I don't want that, I want, oh sure, touch. We'll see how it works here. So go ahead and save that and then run it. And what we'll see is it will go ahead and it will touch that file. And we'll see on the right hand side, those files begin to appear. Now that I see exactly how big they are, I'm gonna make them What I'm doing here is I'm just using the creation of a file to show an example of configuration changes. Environment. Perfect. Okay. So we can see it went ahead and it changed. That was the creation of the file. If I run it again, it's going to, no changes are going to occur, and therefore it will show changes of 0. Correction. Touch can continue to touch a file. Yeah. Alright, so let's go ahead and let's edit that file one more time. And let's say we want to do with some cleanup as well. What we want to do is we want to be able to both touch the file as well as remove the file, depending on whatever options we give it. In this case, I'm going to change the command or the state of touch to a state of file_state inside curly braces and single quotes. What this is going to do is this is going to allow me to add an option on the command line called file state, and whatever I type on the command line will then go in as part of this playbook. So single quote, opening curly brace, file state, closing curly brace, and then single quote. So if we run this, what I do is instead of just calling Ansible playbook with the inventory and the play file, I also add a -e file_state, which is the option that we had in the playbook, equals, I'm going to say absent. And when I hit enter, what will happen is we'll actually see on the right hand side, the 4 machines will see that this file disappears because we're now setting them to absent. And now, since the files are absent, if I run it again, you shouldn't be able to make something absent that's not already absent, so changes should be 0. There we go. Changed, 0. But if I change absent to touch, now it will go ahead and create the file for me. So there you go. It's a fairly short introduction to Ansible, but again, the idea is that Ansible is there to be able to manage the systems. Here we're just using one example of creating files and folders on the machine. The very first play that we created, the very first task that we created, went ahead and created this temp directory. And I did that just so that when we run this watch command here, we would only see the files that we care about, as opposed to the temp folder, which had a lot of other junk in it. The next task that we added in here was to create a temp file specifically for all the machines in our environment. We could then go ahead and get a little bit more specific in here and start adding in other hosts. So for instance, hosts, we could specifically say web, following the same format as what we had before. Great. Web hosts, web files. Destination is going to be /tmp/ans/web. State. And in this case, I'm going to use the same state, just because I want to be able to both create and clean up at the same time. And then let's do another one for the DB. File test/tmp/ans/db and state file _state. Alright, so now when I run this, all the hosts will run this section up here, which will create the temp directory and touch the files, touch the tmp ans file, which are already there. All of the web hosts should then create a file called answeb, and then all the db file hosts will be able to create a temp file. So let's go ahead and do that with the file state of touch, and then we'll see on the right hand side, the web servers will have the web files created, the DB servers will have the DB files created. Yep. And it created it in whatever order seemed to be the fastest at the time. And then to be completely nice, last thing I want to do is I want to clean up my environment in order to move forward with something else in the future. So I mark everything as absent, and it cleans up both the DB, the web, and the files all themselves, and everything good to go. So that was our introduction to Ansible. Again, designed to automate system management tasks. We only talked about a couple of them, specifically with regards to only doing like file management and rebooting the machines. But because it uses SSH, it can work with anything that uses SSH to any degree. Idempotent scripts, you'll notice that we created the directory in our very first task, and it never tried to recreate the file over it. Used our playbook that had lots of different plays in it, and then our inventory file that allowed us to have a lot of configurations, probably more than we actually should for a secure environment.